How do we feel about that tangent stuff? All right, then talk to me about it. Tangent, if we have a triangle, right angle, let's say this is angle A, B, and C, and we're going from the perspective of angle A. What would be the tangent at angle A? Yeah, Mia. BC over AB. Yeah, it would be our opposite over the adjacent. Very good. Now, today we're looking at two more different types of, hey, if you guys are going to be talking the whole time I'm talking, then we're just going to move. Because it's distracting for me and distracting for everyone else. And it happens every day. Today we're going to look at two other ratios, sine and cosine, that are the same idea, where we're going adjacent over hypotenuse and opposite over hypotenuse. But we're looking at those ratios again. So the format of today, almost exactly like yesterday. I'll show you what those ratios are, and then we're going to look at a couple of examples of it. Today, actually, Cole is in our last example, so that's really cool. You didn't even know that, did you, Cole? Now you're wondering what the heck it's about. You'll see. Really exciting. So here are our two ratios. Okay? Sine. We have, if we go, well, sine is always the opposite leg over the hypotenuse. Cosine is adjacent leg over hypotenuse. Now, there's a really nice way that we can remember this, and you've probably seen this on your worksheet. SOHCAHTOA. SOHCAHTOA. So sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent we know is opposite over adjacent. So even on the key and different things like that, you'll see that I just write SOHCAHTOA on the top. Because if you can remember SOHCAHTOA, then you'll be able to remember all of these trig ratios. So if we look at sine, the sine of angle from angle A, we'll just shade it in. What would that be? What would the sine of angle A be? What would that ratio be? It'd be our opposite over the hypotenuse. What if we look at the, I won't go through every single angle, but if we look at the cosine from angle A, it is our adjacent over the hypotenuse. What questions do you guys have? After learning tangent yesterday and how that ratio worked, this is not too much of a stretch. So just like an example from yesterday, find the sine of S, sine of R, cosine S, cosine R. And you'll keep seeing me write it. You'll get sick of it. Writing SOHCAHTOA at the top of my page. If we're looking at the sine from angle S, we're going opposite over hypotenuse. Again, they'd have us round to 4 decimal places. I think we know how to do that, so I'm not going to spend time on it. If we're looking at the sine from angle R, we're going opposite over hypotenuse. Cosine from angle S, adjacent over hypotenuse. And then cosine from the perspective of angle R is adjacent over hypotenuse. Cole, is that pencil sharpened yet, or are you doing okay? There's the electric sharpener in the back if you want to quick buzz it. That's, I don't know. If you look in the tin that has the beans in it, there's pencils in there too. If you need another one. Oh, nice. The bean can? Yeah, we could call it that.
The bean bowl.
Do we have any questions on this? I don't think there is a practice problem on it. So I think we can keep moving. Just like yesterday, except different. Now, here is something that's a little bit tricky to follow. Our sine and cosine, kind of the relationship that sine and cosine have. Like it says, they're complementary to each other. Now, before you should have blocked that out first. What do we know about complementary angles? What are? Right, they're 90 degrees. Now, if I told you that we had one angle that was, let's see, 30 degrees, and it was complementary to, if angle A was 30 degrees, and it was complementary to angle B, what would angle B have to be? 60, right? If they're complementary, they have to add up to 90. Now, sine and cosine are complementary, which maybe I gave it away by having that up first. But sine and cosine are complementary. So we can rewrite sine. What the directions will say sometimes, like you can see here in the example, is it'll say something like write sine of 56 in terms of cosine. And all we need to do is, since they're complementary, we can take 90 degrees minus whatever that sine we start out with, and it would be the same thing. So the best way to look at it is our example here. If we want to write sine of 56 in terms of cosine, remember cosine and sine are complementary. Go for it. Perfect. Thank you for getting us back to where we need to be. Sine and cosine are complementary. So we can take 90 minus whatever that original sine degree is, and we can get what that cosine would be. And we can do the same thing the other way around, which you'll need to do in your example. There they are. Now we're jumping already to finding and solving for side lengths using sine and cosine. All right. Now, depending on the situation and depending on what they give us, will make a difference on whether we use sine or cosine. So you'll see what I mean here in a second. We have our angle is 26 degrees. And if we start by looking for x, we have the opposite and we have the hypotenuse. If we are given the opposite and the hypotenuse, which one of our ratios will we have to use?
Oh, I know this one.
Mia says sine. Do you agree, Alton?
Yeah.
Yeah? Right, because we have the, well, we're looking for the adjacent. Wow, we're looking for the opposite. And we have the hypotenuse. So that means we would be using sine. So the sine of 26 degrees equals x over 14. We're going from the perspective of 26 degrees. Now, do you have your calculators? Does everyone grab a calculator?
No.
What? Grab a calculator.
Whoa. You just want to get over that table or crawl over.
Now, even for those that already have a calculator, what mode do we need to make sure our calculator is in? Degrees, yeah. If at the top it says radian, then we need to change it to degree mode.
Why does it say thick?
Say what?
Why does it say thick on it?
Can't tell you. I don't know.
Dot says thin, dot thin.
Now, we have sine of 26 equals x over 14. So I put sine of 26 over 1 because it's the same thing. We cross multiply to get rid of our fractions. Sine of 14, or 14 times the sine of 26 gives us x. What do we get when we plug that in our calculator? 14 times the sine.
10.07075772.
I got something even smaller than that.
What? 14
Times sine of 26.
Oh, I did 46.
Oh,
Whoops.
I got 0.069.
that seems 0. Well, did you just put in sine of 26? 14 times the sine of 26.
6.1371.
There we go. Perfect. Now, if we are looking for y, we're going from the perspective of 26 degrees. We have the adjacent, and we have the hypotenuse. Which one of our ratios will we use? Will we use sine again? Cosine, right? Because cosine is adjacent over hypotenuse, and that's what we're looking at, adjacent over hypotenuse. Now, what do we get when we put 14 times the cosine of 26 into our calculator? Perfect. Good. Do we have any questions before you guys practice on your own? It's not too bad. If we can remember SOHCAHTOA and if we can solve these ratios and set them up, then we're going to be in good shape.
Why do you need to remember something?
Because that tells us what our ratios are. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that helps us remember. Now I know you can use notes, so that makes it pretty laid out as well, but that'll make it a little bit quicker. All right, go ahead. Take a couple minutes. Yeah, take a couple minutes. Work on those 3 problems, and then I have a few more examples and things to point out. And then that will be a wrap. Yep. Yeah. And just like yesterday, we'll need to see, you'll need to prove to me that we have done something with our warm-up and our practice before getting the worksheet. Also, there are 2 assignments today, so we might not want to mess around for too long. 2 assignments. Yep.
Set it up like this, and then grade it like
Does that class take work?
So would it be 7 over 25?
Log back out. Here, load the class code up again. You can type it in again.
Yeah, so it is 7 over 25.
There it is. Nice job, Daniel. Yeah.
That would just be this 25. Sine D was opposite hypotenuse. And now cosine D is adjacent.
You need what?
Yeah, I know. It's the same thing I got for sine M. Cosine D is the same as sine M.
Right, so just like you did, sine of D equals.
So is that all you do?
Yep, that's all you need.
And that would be like cosine M.
So
Sine D.
You're not solving anything here.
Sine D is the same
You're
as
just getting used to the ratio that sine is opposite of hypotenuse.
yeah.
Now what we'll eventually be able to do is be able to find what that angle is from the
Adjacent dividing into
Same as sine D.
so it'd be 24.
Same as sine D. Sine D.
We will go about 1 more minute. What's 1 more minute in Spanish? Uno más momento. Momento, uno más.
I don't remember.
Is anyone good at Spanish?
I finished both tries, both years, and I have no idea.
Oh, good. That's all right. I took a total 1, 2, 3 years of Spanish. I can't even say 1 more minute. So, what does that tell you? I think it's un más momento. Un.
It depends on how you want to say it.
I want to say 1 more minute.
Well, if you want to say like 1 minute to yourself, you do it in momento.
Oh.
Okay, something like that.
Hmm.
It kind of depends on how you're addressing people with it.
Gotcha. Nope, not that one. All right, let's keep moving so that I can get through these slides and then you guys can get working on your homework and everything. So I just want to show this. I just want to show this and talk about it for a second. This is something more that will come up in, I can't remember if it's FST or I think it's FST. So if you continue with your math career, you will see this again, but I'm not going to stress about it right now in geometry. Find the cosine, the sine and cosine of a 45-degree angle. Now we know our 45-degree, we have a 45-degree angle, that we have 45, 45, 90. We know that these are x and x, and we know that this is x times the square root of 2, right? That's our 45-degree angle setup. This is how we've, in the past, found different sides in a 45-degree angle. Now, in this situation, they're saying that x is equal to 1, so we have 1, 1, and root 2, like you can see. Now, if we were finding, let's say, the sine at this 45-degree angle, what would the sine be? Well, it would be 1 over root 2. We don't like square roots on the bottom. So we'd have root 2 over 2. Now, again, you guys might be thinking, like, who cares? What does this matter? There are some sines and cosines, like I said, when you move up in math, that you'll need to memorize that are part of what's called the unit circle. You guys probably haven't looked at that yet, but eventually there are some like staple sines and cosines, like sine of 45, cosine of 45, that you'll want to have memorized. Sine of 30, cosine of 30, and some different ones like that. And this is just where they come from. That when we have a triangle with a 45-degree angle, we like opposite over hypotenuse, and square root of 2 over 2 is what that would give us. So again, hopefully you can. What I want you guys to take away from this is our sine at a 45-degree angle, opposite over hypotenuse. It will always be this ratio, the square root of 2 over 2. No matter how big of a triangle we have, no matter how small those sides are, the sine at a 45-degree angle will always be this ratio right here. So I guess that's all we'll look at with that. You'll use that way more later in your math career. And we could go through the same thing with a 30-degree angle. If we have a 30, 60, 90 triangle, that the sine and cosine will always be the same ratio with a 30-degree angle. There's your practice problem, which I will let you guys get to. I want to talk about one more thing, and then I will be more quiet for the rest of the hour. Yesterday we talked about angle of what? Does anyone remember? What? Yeah, it's angle of elevation. We had the example of Chaz was out pushing over trees, or who was pushing trees? Alton was pushing trees, my bad. And then the bird was coming for him. He looked up at the bird, and that angle from his eyes to that were parallel with the ground. Yes? Oh, my bad. I think I only drew one bird, but a flock of birds were coming at Alton. Yep, so he was looking at all of them at the same time, so that's kind of crazy. But the angle from where he was looking to the ground, or like parallel with the ground, was our angle of elevation, right? From the ground, elevated up. Now, what comes out of this lesson would be our angle of depression. In this case, and they like to use an airplane flying a lot of times, but in this case, you're up, maybe lifted on a stand or on a stage or whatever, and you're looking down at something, okay? Or like we're going to see in our example, Cole is doing something else. But angle of depression is the angle from here going down. Elevation is ground level going up.
Can I guess what it is?
Yeah, no, you see, you have the slides. You can't guess.
I swear I'm looking at Cosine.
Okay.
It's going to be tall underground.
Nope. Well, in a sense, you could be underground.
No, like the material pool.
No, it's you. Cole is skiing on a mountain with an altitude of 12,000 feet. You could be underground if an avalanche came, But Cole is skiing on a mountain with an altitude of 12,000 feet. The angle of depression is 21 degrees. So Cole is starting. Oh, Cole has long hair in this picture too, it looks like. Cole is starting at the top of the mountain. From the top of the mountain, if we were to draw a line just straight out, and then draw a line that goes with the angle of the hill, we've got 21 degrees. If Cole was thinking, I know I'm 1,200 feet up, I want to figure out how far down this hill is. And he brought his compass, so he could know that the angle of depression is 21 degrees. Well, next time he goes to Colorado, where did you go? Yeah, you went to Colorado, you said over spring break. Next time you go skiing, you can bring your compass and you can figure all this stuff out. We could solve, or Cole could solve for x to see how far he's actually skiing down the hill. Now, we have, let's see, x would be our hypotenuse. So we have our hypotenuse. 1,200 would be, let's see, that would be opposite, wouldn't it? So we would need to be using sine. So sine of 21 times x equals 1,200 times 1. X equals 1,200 over the sine of x. Cole, how far did you ski down the hill? Let's go. Punch in your calculator. 1,200 divided by the sine of 21. Oops, not sine of x. Sine of 21. My fault. How far did you ski down the hill?
3,340.5.
You had the right numbers. Maybe I made it 33 feet.
Do I agree? Yep, I agree. I do. That's all right. He might have forgotten some zeros or something. But isn't that sweet? As long as you bring your compass wherever you go, you can figure out a lot of stuff. Compass, a tape measure. You can figure out all kinds of stuff. So thank you, Cole, for helping us put math into real life. But do we see how this would be, I mean, all joking aside, do we see how this is angle of depression? Because we're starting up high and it's the amount that we're moving down, or our angle is below us. The angle of elevation, the angle is above us. What questions do you guys have? Anything? Is it? I said they kind of have long hair. Oh yeah. Whoops.
Did you just assume bullshit?
All right. Get that class kick finished up.